Hello, this is a Senior Design 2 Expo poster for Spring 2022 for the Caper Load team. As a general overview of the project, the team has been given 3 years of data from the sponsors to develop a machine learning algorithm to control the battery energy storage system and also determine the future load profiles and the battery state of charge. Our team's mission statement is shown, also our project specifications. The feeder is one of 2 feeders in a bank. The circuit appears to be winter peaking and 59% residential. As for critical components, the feeder has 3 switch capacitors, 6 reclosers, and no line regulators. The batteries being used are Samsung M3F lithium-ion batteries. The battery is on a tap line protected by a Viper recloser. The site was chosen because it is directly next to the op center, and the site has a total battery installed capacity of over 15 megawatt hours. Our 3 main scripts are data categorization, LSTM, and SymPy, which has been programmed through Python 3. One of the important tasks we attempted to tackle within this project was data categorization. Data categorization is the action or process of placing data into groups of categories. For our purposes, we split our historical load and weather data mainly based on the 4 seasons and whether a day was a weekday or weekend. Additionally, we attempted to further our categorization through subcategories with the climate, with description of hot, dry, hot, wet, etc. It should be mentioned that determination for these descriptions are based on historical weather trends that were observed in Gainesville, Florida. LSTM is the algorithm we chose to perform load prediction. It is a type of recurrent neural network that uses sequential data or time series data. The graph shows the prediction the algorithm has on a validation set of data, which is the last 10% of the data. The table shows the 1 hour comparison from our prediction to actual data we have from our supporters. As seen in this first hour prediction, there is between a 5 to 10% error between the prediction and actual data. For SymPy application, the goal is to automate the load allocation and load flow process. The intention is to have the algorithm project the load and have the projections imported into the SymPy script. SymPy will run the load allocation, and shortly after, load flow will be run at the feeder breaker and at the point of interconnection. The load flow summary report will be exported along with the load flow results into a designated report bin. Below, a projection using 2 days of trained data was allocated into a feeder to provide a sample feeder response. The provided data includes VBase, which is the average of the lowest and highest downstream feeder voltages, the line-to-line and line-to-ground KVs, load current per phase, the apparent power in kVA, the real power in kW, and the real reactive power in kVAR. The station exit voltages are fairly balanced at 120. However, this could also be partially attributed to load allocation being run as a total as opposed to being done per phase. And this is our overall logic flow diagram. Thank you.